Okay, so we had, talked about the sampling methods and basically how the different techniques can be used in collecting a sample. The second half of the handout here talks about, biases, how statistics can be misused, but, a lot of times you may not be doing it intentionally. It could just be something in the way you're saying or doing that can bring that implicit bias in there. So, but here, we're kind of talking about how it can be done by people, businesses, advertising firms that can misuse, statistics for their own advantage. Because, a lot of times people tend to believe when they see statistics, but, they will not go too in depth in thinking about, well, how was this data collected or how did they perform the study. So sometimes, we have to be careful when we see these, statistics being thrown at us. So here they're talking about, when you examine some of these information that's being sent, think about, was that sample unbiased? Was the sample, large enough? Because again, if you keep a sample too small, uh, your results can be advantageous to you. So, you can kind of show that, oh, we studied so many people and this is what we came up with. So this works. So a lot of times you do really want to have a nice, good, large sample size if possible. Think about, can the statement be interpreted in more than one way? So is there, more than one way of looking at it and understanding the information that's being shared with us? Also, be on the lookout for vague words. So, and we had talked about this when we have looked at measures of central tendency in chapter 4, the first part. So when we talk about average, remember average can be your calculation for mean, median, mode, or mid-range. So there's 4 different calculations that can still be assumed to be an average. So, when they use the word average, well, which calculation did they use? Because that can make a big difference, as we had seen in some of those examples. Even words like largest and best can be pretty ambiguous because, in reference to what are we talking about these being the largest or the best. So, sometimes you have to be on the lookout for what kind of language they are using in, these advertisements or whatever the case might be. Bias can occur because of the way a question is worded. So literally how you ask a question can already have a bias built into that. So they're saying in a golf ball advertisement, a spring ball and another ball were hit in the same way. Spring ball travels much farther than the other one. We are supposed to decide spring ball is a better ball because, of course, you're talking about it traveling farther than the other one. So they're saying what was not mentioned is the number of times the experiment was performed or the results of the previous experiment. So, they're not giving you any of that background information. So what could be some of the possible sources of bias over here? Why did one ball do better than the other one? So you can think about wind speed, wind direction. No 2 swings are going to be identical. The ball could have landed on rough or smooth surfaces. So, if it's going to be smoother, it's going to travel farther. If the surfaces are rough, then it's not going to travel as much of a distance. So, again, just different components, I guess, could have affected, how the 2 balls performed. I haven't seen these commercials for a while, but Trident gum, chewing gum used to have this commercial where they would have, 5 people sitting at a table and they were supposed to be these experts, dentists who were recommending the Trident gum as good for your teeth, so you can chew this gum. So what they would do in this commercial is, the 4 people would be okay and they would, hit their little buzzer for saying, yes, we approve Trident gum. But the 5th person the fifth, expert, I think in one commercial he had like a squirrel climb up his leg, through his pant trousers. There's something else happened. So each commercial was different where the fifth person, was getting attacked or, whatever. So he never hit the green button, and I guess he went and hit the red one. So the idea behind that is, what companies will do if they want that statistics to be true, that 4 out of 5 dentists approve our gum, they will literally pick group of 5 scientists, or I guess dentists in this case, from different areas. So they will have, multiple groups of these 5 dentists, and they will keep asking these groups, do you recommend our gum, our Trident gum? And they will wait till they find that one group out of how many ever hundreds of groups they may have selected, till they get that statistics of 4 out of 5 said yes. So that does not mean that every time they did the study or every time they asked the dentist, they got that answer. They will keep repeating that experiment till they basically get the result that they are looking for. And that's kind of what the spring ball, golf ball experiment, advertisement is talking about. Is, they're not mentioning how many times they did the experiment, what were the results of those experiments. It could be, if they did this experiment, let's say 10 times, maybe 9 out of the 10 times the other ball performed better. But in that 10th experiment that they did, the spring ball performed better. And that's all they need, because they can say, look, we did this experiment, this is the result we got, that's why we're saying this ball is better than the other one. So like they're saying, you can misuse statistics for your own benefit. So here they're talking about information from research studies is sometimes taken out of context, and they're asking us to explain why the claims of these studies might be suspect. So, we're trying to figure out what could be a bias built in here. So they're saying the average salary of the graduates of the class of 1980 is 32,500. So what do you think could be an issue with that statement?
You don't know which average they're using.
Exactly, very good. You don't know which average they're talking about, because that could be a median. So, right in the center, that could be the mode, mean or mid-range. So right there, as they told us before, look out for those vague terminologies. So average. Second one is saying it is estimated that in a city, there are 27,256 cats. So what could be suspect about this statement?
It's really vague.
The number is really large. Yeah, what else?
The wording is vague. What city?
Yeah, so what city? And then they're also telling you it is estimated, but then no real information about how they came up with the estimation, right? So we don't know what city they're talking about and how they honestly came up with that value. Only 3% of men surveyed read Cosmopolitan magazine. I'm not sure why that is such a big deal, but okay. 3% of men surveyed read Cosmopolitan magazine. So what might be suspect about this statement here?
We don't know how many men they surveyed, maybe.
Yeah, they're not telling us what our number of our total group of men was. So we don't know where that information is coming from. Very good. Based on a recent male survey, 85% of the respondents favored gun control. So based on the recent mail survey, so something they sent out in the mail, 85% of the respondents favored gun control. So we had kind of touched on this a little bit last time when we had talked about, our convenience sampling, and this example over here where we talk about viewers of a nightly news program are asked to call in and express their view on a topic. Because remember what we had talked about was, there's most of the people who are going to call in and express their view are probably the people who watch this on a regular basis. You can say they are fan of the program, more than likely they agree with what's being said on the news program. So these are actually people who are already leaning towards, what's going on with the show. So their responses, as you can imagine, is going to be very close to the news itself. So that's actually the kind of thing that happens, because think about mail-in survey. You, and if you really think about it, there are so many different mails that come through. A lot of times we just want to go through the important ones and get rid of all the extra junk mail. And that's what mostly happens with these mail-in surveys also. And so think about the people who are actually going to take the time to fill out this survey and send it in are probably, the people who really feel strongly about gun control. If people are opposed to it, more than likely they actually did not even bother sending it in, right? Because they're like, who cares? I don't, support this matter or this standing or, whatever the survey questions might be. So what's happening in here is only those people are responding who are actually already in agreement or in favor of what, the survey was about. So there's actually nothing so much in the language itself, but since you know that these are mail surveys, people who are in favor of a certain position are the ones who are going to be responding. All right, let's look at the next one. A recent study showed that high school dropouts drink more coffee than students who graduated. Therefore, coffee dulls the brain. And I love that statement. I don't know who even bothered to do that study, but it just amazes me how, based on this study, they are saying, the conclusion is coffee dulls the brain. So a recent study showed that high school dropouts drink more coffee than students who graduated. Therefore, coffee dulls the brain. So what could potentially be the bias or the suspect about this statement here?
It just sounds very exaggerated and ridiculous to me.
Yes, it definitely does. And I agree with that. But just in a more statistical way, what else can we kind of point out in this?
It doesn't give you any numbers. It just says.
Riley, your sound is a little on the softer side.
Oh, it doesn't give you any numbers. It just says that. So there's like no proof.
Okay, I actually still have trouble hearing you.
She said that it doesn't have any numbers. It just says something.
Yeah, so one thing, they're actually not even telling you a whole lot of about how they conducted the study, how they calculated their information. For that matter, what was their population and sample also, right? Because they're just talking about high school dropouts versus students who graduated, but was that really their, thank you, was that really their population, or was that, something that just came out of whatever study that they were doing? So there's actually a lot of unknowns that are in over here. And, think about, normally, why do people drink coffee? Are any of you coffee drinkers? Me neither.
To wake up though?
Yeah, a lot of
I'm a
people.
coffee drinker.
Are you, Roman? So what's your reason behind it?
Well, I think honestly my mom got me into drinking coffee when I was like in middle school.
Oh,
So
okay.
I've just been drinking coffee since then.
So is it just a habit that you have, or is it something, kind of like how people talk about, I need my first cup of coffee to start my day. So is it more of that, or is it just a habit for you?
Um, I think it's more of a habit. I don't necessarily need coffee to start my day,
Yeah.
but something about just kind of like the ambiance of having a cup of coffee, the smell and
Yeah.
the warmth of it just helps me feel centered sometimes.
Right, right. Yeah, and so that's the whole idea behind this, right? A lot of people drink coffee to, like, I have one of these friends whom I talk to, and she always starts her day with a cup of coffee, and she's like, don't even talk to me till I've had my cup of coffee. So a lot of times it's that stimulant that people are looking for, right? To get their day started. So it's kind of interesting that they are claiming here that it's actually having the opposite side effect that the coffee does the brain. And so, like I said, there are so many unknowns about this whole idea that leaves a lot of questions than answers. The other thing I would also point out is, even though they're talking about high school dropouts, think about how many students who dropped out of high school will still go ahead, get a GED, and still go to college, right? We have a lot of students at Ames we see who took their GED and came back to school. So do we know that these high school dropouts are, students who didn't go back to school, or they just dropped out of high school but did go back and get more education? So statements like those should be, sending red flags no matter what. All right, guys, good job. Let's see. Since most automobile accidents, and this is another one of those statements that gets me cracking up. Since most automobile accidents occur within 15 miles of a person's residence, it is safer to make long trips. So what would you guys say about that?
Well, you still have to drive back home. So
Yeah. Well, and think about longer trips, why they could potentially be unsafe.
If automobile accidents happen while driving, then the longer you are in a vehicle, the higher the chance you are to actually get in an accident.
Yeah, and especially if we talk about longer trips also, if you've been on the road for a longer time, you are going to get more tired, right? So that means you can potentially be in a little bit more danger. And again, the question is, they're talking about most automobile accidents occur within 15 miles of a person's residence. So you kind of have to beg the question, is this only a residential area? Or a couple miles outside of your area, you're getting into some other types of zones. Is it going to be commercial? Are you closer to I don't know, train tracks or something like that? I mean, there could be so many other reasons. So again, there should be so many unknown factors over here. And again, the idea is, where did they do this study? Where is this information coming from? Is this all over the country, or is this a particular part of the country, one little area, one little city? So again, not a whole lot of information that you have about here in terms of that safety. All right, this is, I believe, our last one on this guy. So in light of Mayor Smith's recent arrest on moral charges, do you feel that he is doing a good job as mayor? Give a number from 1 to 10, with 1 being a poor job and 10 being a great job. So in light of Mayor Smith's recent arrest on moral charges, do you feel that he is doing a good job as mayor? And then you're ranking this person.
There's no specifics on what the moral charges are, so
Okay.
we can't decide if his charges are moral or not.
Okay.
as well as ranking from 1 to 10 is pretty vague, and everybody's 1 to 10 could be pretty different. Or
Yeah. And if I Let me ask you this. So we don't know, Mayor Smith, like Roman mentioned, we don't even know what those charges are. But how is the wording of this question creating a bias? Because what happens when you tell somebody, oh, the mayor of this town got arrested on some moral charges? How do you think a person would react, even if you don't know who this mayor is?
Automatically negative.
Yeah, because you are kind of thinking, moral charges, which means they must have done something, morally wrong. Though we have no idea, it could be something very, very minor. And maybe even using the word moral could be a leap from what they did. And so they're actually putting that bias in the question by saying, the mayor basically got arrested recently. So how do you think, he's performing on his job? And like you said, it's going to lean you towards the negative. Only the people who are in the know or probably know this person really well would give him that benefit of doubt and say, I think, it's completely different. So this is kind of what they were talking about, how sometimes you create a question, can create that bias in this. So the bias can occur because of the way the question is worded. And that's exactly what they did in this last one by giving you those, background information, but not really good background information either. So this is where that implicit bias came into play. So what you guys have, and I will see if I can show you that. So in your D2L course shell under chapter 4, you will see right at the bottom, you have the assignment handout over here, the sampling methods and bias homework, which is what this handout here is. So the first part of the handout is asking you questions on the different sampling techniques, the sampling methods. So you just have to identify, out of these 5 sampling methods, which ones were used. And then the second part of the homework is asking you to explain why the statements might be suspect and what kind of bias might be occurring in this statement. So you've basically got 9 on the sampling questions and 6 of these on the bias question. So I want you guys to work on this. And I'll make the due date for this next Wednesday, because since you guys are finishing up your chapter 4 homework and exam in WebAssign, I'll give you a little bit more time to work on this. I mean, if you want to turn it in sooner than that, that's fine. But, we'll keep the official due date for this as Wednesday, which would be 27th of October for us. So we'll make this due on Wednesday, October 27th. And I'll put the updated message in D2L, and I'll send you guys a reminder about it through remind.com also. But if you just wanted to write it down for now, you can. So the homework on bias and sampling will be due October 27th. Any questions before we move forward from here? All righty, perfect. All right, guys. So we're starting out our next chapter. And this next chapter is actually fairly small. There's only 2 sections we're looking at here with simple interest and compound interest. So I'm actually combining chapters 5 and chapter 8 together. So we'll take their exams together like we did for chapters 2 and 3. All right, guys. So here we're getting into, some basics about financing with, simple interest and compound interest. So let's take a look at some of the terminology first. So when we're talking about, you can think about either you are getting a loan or you are making an investment. So, the terminology usually will stay the same. Now here they're talking more in terms of an investment. So they're saying, if the terminology of principal means it's the amount that's being invested, But, even if you were taking a loan, that would be the amount that you are borrowing. The interest is, of course, how much money you will earn if it's a investment you're making, or how much money you have to pay for borrowing, this principal amount. So that can also be your interest. Your interest rate is, based on a percentage. So how much interest do you end up paying is calculated on, a percentage. So even if it's an investment, you earn a percentage, based on your principal or the interest you pay if you're borrowing money. And then, of course, the time is how long are you keeping the investment for, or how long you're taking a loan out for. And normally time is always calculated in years. So you will see your time, T, is going to be in years. Your principal amount and the interest amount will be dollar. And then, of course, your interest rate is going to be a percentage. And again, keep in mind, by default, whenever we're working with percents, we always convert our percents to decimals. So just to show you a basic example over here, using our simple interest formula, which is this guy over here, I equals PRT, which means you're technically calculating the interest, which is the dollar amount, by taking your principal as a dollar amount, multiplying it with your decimal for the rate of interest, and multiplying it with the time in years. So PRT basically means you're multiplying P times R times T. So here in this example, they're talking about Tom and Betty buy a 2-year CD. So that's a investment plan, you get through the banks, and they will be receiving a simple interest of 5.1%. And looks like they want to, invest $150,000 for this CD. And, of course, they're telling you it's a 2-year CD. So that's going to be our term, right? Our time frame. So you've got your principal, which is the amount they want to invest, $150,000. They're telling us the interest earned on this CD will be 5.1%. So just convert that 5.1 to a decimal. So remember, you take 5.1 and divide that by 100 to convert it into a decimal. As I mentioned, it's a 2-year CD, so your time frame is going to be 2 years. So you've got your P, R, and T values. You multiply all three of these numbers. So you're multiplying 150,000 with 0.051 with 2, and you will see when you perform that multiplication, you are going to be looking at an interest amount of 15,300. So that means over this 2-year time period, Tom and Betty will have earned $15,300 as interest on their, principal amount of 150,000. So basically, if you take that principal amount of 150K, add the 15,300 to that, that will give you a total of $165,300, which means that at the end of 2 years, if they decide to, remove the money from this CD, if they don't want to continue investing it and they just want to cash it out, they will end up getting $165,300 at the end of those 2 years. Now, of course, keep in mind with these kind of investments, if you remove your deposit earlier than the maturity date, you end up, losing some of your interest. There will be a penalty and stuff. So this is the idea here, is you keep the money for that entire time period, wait till its maturity date, and you will be able to then cash in all that 15,300 that they are earning. So that was just a basic example to kind of get us going. Just to update on our simple interest formula. So when you added the principal with the interest, that's what we call as the future value. The future value, came out to be this 165,300. So what they are doing is they're using, that same formula, principal plus interest, But we know the interest formula is P times R times T. So what they're doing is taking that I value and replacing it with PRT. And then since I am adding the principal with the PRT value, they're using basic algebra over here. So you've got P plus PRT. Both of them have a P in common. So you bring that common P outside. So since I'm taking this P value outside, I replace it with a 1. Plus this P value also I took outside. So now I'm just left with RT. So this is actually the updated formula for simple interest when you have to calculate your future value. So it's principal parentheses 1 plus RT. So what this does is gives you directly what the future value of your investment is going to be. And so you don't have to separately calculate the interest and then add it back into the principal. So this formula can be used if they just want to know what the future value is. If the question is asking you just to find the interest, not the future value, but just the interest, then you can use that first one, I equals PRT. So just based on what question you have, if it's the interest, use this one. If they want to know what the future value is, you can use this one. So this was your basic setup for the simple interest, but let's take a look at, how simple interest can be used in different types of, applications basically. So we're talking about short-term loans over here, and this is usually means, a year or less than a year. So that's what we consider as a short term. So in short-term loans, you actually have to calculate for how many days you are taking the loan out for. So just to again highlight an example over here, they're telling us Esprit Clothing borrowed $185,000 at 7.25% interest. But because this is a short-term loan, they're only borrowing money from January 1st to February 2nd. So we know that's about 2 months time, but you actually don't use your time as 2 months. You have to calculate how many days you have from the beginning of the loan till the end of the loan. So that's the first thing we have to do. So we know January has 31 days because you're starting on January 1st. So that's 31 days from January. And then February we know has 28 days. But remember, your loan will mature on February 28th. So technically, you're actually only using 27 days from February. So all of 31 days from January, 27 days from February, add them together, and that gives you the time frame for how long this loan is being taken out for. So that's going to be your T value. Now, remember what I told you before. Your time is always in years. So we cannot leave that time in days, which means even though we know the loan is being taken out for 58 days, we have to convert days into years. So 58 days, 365 days in a year, you're actually taking 58 and dividing it by 365. And they're showing you using dimensional analysis over here, how you can change your time from days to year. And that's basically by, multiplying by this little fraction over here. So 58 days multiplied by 1 year divided by 365, which is the same thing as 58 divided by 365. And now we have this in years. So your principal, how much money they were borrowing was 185,000. The rate of interest on this loan was 7.25. So that's basically 7.25% divided by 100, and you end up getting 0.0725. So that's our rate of interest. So we're putting it into our future value formula using simple interest. Principal 1 plus R times T. Finish that calculation and you can see what this number comes out to be. So by the time this loan will be paid for, the Esprit Clothing will end up spending $187,000 $131.30, because 185 was their loan amount. So you can see for about 2 months time, they're paying an interest of what would that be, 2,131.30. Just subtract the two numbers, and that's going to be your interest that they pay on this loan. And that's kind of what they're talking about. They're talking about, of course, your future value has to be larger than how much you borrowed because you add the interest to it. And then over here, they kind of talk about why we cannot use, a calculation of 2 months divided by 12, to convert it into years. And that's because some months are longer, some months are shorter. So they don't have the same amount of days in each month. And that's why this calculation will not work. You have to use the days to make these type of calculations. Another thing that they talk about, and a lot of financial institutions will do this, instead of using 365 days per year, they will actually end up using 360 days. And instead of using, 31 days, 28 or 29 days for February, 30 days for some months, they actually just end up using 30 days for each month. So, it doesn't matter which month it is, they will just go by 30. And the reason they do that is, a lot of times this works in their favor, because if it's an institution giving you a loan, they will end up getting a little bit more money if they use 360 days in a year or 30 days in a month. I mean, they're obviously going to want to do what's beneficial to them. But your textbook is going to use 365 days and then, whatever the months are based on those calculations. Just some more terminology over here. The contract signed between the lender and the borrower is what we call as a note or loan agreement. Your maturity value is just basically what the future value of your loan will be, once it's paid off. They actually have a couple different examples here. So they're kind of showing you how you can use the simple interest calculation to see, what the interest rate for our national debt is. And this was based on the 2013 value. So you can kind of walk through this example over here. They've got a couple different examples, here where how much money will be worth in the future. So you have your future value. You're actually trying to find how much money you want to invest now. So, this can be something like future planning. If you plan to take a trip, in 2 years time, and how much the trip is going to cost, you can say, well, I want to save this money, based on whatever the interest rate your bank might be giving. You can say, okay, so how much money should I deposit today so that in 2 years time, I'll have the money for my trip. So that's kind of what this future value calculation will be. So you've got a bunch of different examples over here you can go through. Let's find examples, in our textbook, and we'll take a look at our own examples here. So let's see what would work for us. Okay, let's do one of these examples with the short-term loan. So we actually get to calculate, how to work with those different days in each month. So how about for now, we'll look through number 10 over here. So your instructions for number 10 are, just find the simple interest of the given loan amount. So that's just our instructions. And then let's look at number 10 itself. Okay, right over here. Okay, so you can see for number 10, we are borrowing $5,682 at 11.75%, from July 1st. So we need to start looking at part A, and then we'll look at part B. So they are saying you're starting from July 1st and you're going to December 31st of the same year, and they're saying going through December 31st of the same year. So the date is the same, but the words are to December 31st, and the other one says through December 31st. So your calculation is going to be just a little bit different between those two. So let's go ahead and take a look at this guy here. So I'm actually going to move this over to our notebook here. So we are borrowing, so that's going to be our principal of 5,682. Our rate of interest is the 11.75%. So we will need to convert this to a decimal. And then, you know, our time is going from July 1st to December 31st. But, you know, we, like I said, our calculations are going to be a little bit different for parts A and B. Part A says to December 31st of same year. And part B says through December 31st of same year. So let's do our time calculation first. So we need to know how many days we are looking at. So you've got July, August, September, October, November, and December. So how many months from July are we using?
6.
Oh, sorry, I didn't mean months, days, because we will have to do this with days since each month is going to be different. Sorry, Roman.
180 then?
Say that one more time.
180, because I'm just doing 6 times 30.
So yeah, and that's where we will need to be careful, because even though, you know, they were telling us some of the banking institutions will do 30 days for each month, we are actually going to have to calculate specific. So July, we know, is, 31 days. So we will actually have to use those exact numbers. So 31 days in July. August also is 31 days. September is the shorter month, so that's 30 days. 31, of course, in October, 30 days in November, and technically 31 days in December. Now, the difference here is when they say to December 31st, how many days are we using, and are we actually using December 31st itself in our total calculation? So go ahead and add up these days over here, so at least we know how many days we are looking at, and then we'll have to make adjustments based on part A and B. So it will be a little bit more than 180 that Roman mentioned before, because of those, you know, days in there with the 31. So what total are you looking at here, guys?
184.
It will be 184, yeah, because of those 4 months with the 31 days in there. So when they say to December 31st, are we looking at 184 days? No?
183, I think.
Yeah, because they're saying you're going to December 31st, which means you're not actually using December 31st in the calculation itself. So that's why you're going to have 1 day short, because you're not taking December 31st into your calculation. So you're actually only using 183 days as your t-value in part A. Of course, our principal and rate of interest are going to stay the same. So can you tell me what that 11 3/4 turns into as a decimal?
$11.75.
Okay. But it will still be a percentage, so we still need to convert this to a decimal form.
0.1175.
Yeah, so divide that number by 100 and you get 0.1175 for your rate of interest. Principal was 5,682. So now we are calculating, hold on, I think they wanted us to find the simple interest only here, didn't they? Yeah, they just want us to find the simple interest. So we're actually using the I equals PRT formula. So that's 5,682. That's our principal. We multiply this by a rate of interest, which was the 0.1175. Multiply this by your T, which is 183. But remember, again, since this is given to us in days, to convert it into years, you divide this by 365. So this will be, in years. And then since we're talking in terms of, money, dollar amounts, let's round it to 2 decimal places. So that will be the nearest cent. So you can share your answers once you're ready in the chat with me. So round it to the nearest cent, which will be 2 decimal places. All right. So let's see what you guys came up with for your answer. Okay, Logan, I see your answer. Okay, did I see, Roman, did I see your answer? No? Okay. Are you able to come up with the answer though?
I'm still working out the calculation, but
Okay.
it's pretty close to Logan's.
Okay. So just to show you guys the raw answer, it comes out to be 334.732. And since you have a 2 after that 3, of course, when you round it, you end up with the answer you see that Logan shared with us, 334.73, so 73 cents at the end. Alrighty, perfect. So again, guys, that's really the only difference you are seeing in parts A and B. So since part A said to December 31st, you were not actually including December 31st in your calculation. So that's why we only had 183 days. Part B says through December 31st, which means you're going all the way till the end of December 31st. So the only difference between part B is going to be, instead of 183, now you use all of the 184 days. So you don't have to remove that one day at the end. So it will, as you will notice, have a little bit of an effect on your calculation, but obviously just a difference of one day. So let's see what these numbers will come out to be. So you guys can go ahead and do your calculation and share the answer with me while I'll go ahead and write all of this out. So the only thing is you're changing that 183 to 184. All right, Logan. Hey, Roman, same thing. All right, very good. So again, just as your raw answer, it comes out to be, of course, you will see our dollar amount changed a little bit because of that difference in our time. So you're going to 336.5612. So again, that keeps us at 56 cents at the end. So just a little under what, $2 of difference between 183 days and 184 days. It's actually more than I had anticipated. I thought it would be just a difference of couple cents, but just under $2 is still not bad. So just that little tiny difference between the difference of one day. So you will see there's a couple different examples here where, depending on the terminology, you will have to calculate your days. Some of these examples up here, you will see how they're giving you to and through, between your different dates. So just be careful about that as you are going through your homework. Now let's see if we can do one example, maybe an application instead of just these ones. What does 24 look like? Okay, how about we'll change it up a little and let's do number 28 over here. So number 28, they are saying if you borrow 1,700, so if you're borrowing that, will that be your future value or your principal?
Principal?
Principal.
Yeah, very good. So this is going to be our principal. You of course got your rate of interest over here. And then they're telling us the loan requires a lump sum payment of 1,863.12. So, of course, that's what you're paying at the end. So this tells us this is going to be our future value. So what they're actually asking us to find is what is the term of the loan, which means they're asking us to find the time, how long are we keeping this loan for? So that's what we're actually trying to find. So just a little bit of a change on, the same formula for the simple interest, but finding the T instead of, the future value. So again, let's go ahead, write all of this information down. So we'll move it over here again. Okay, so you are 28. We are borrowing $1,700. We have to pay back a lump sum of $1,863.12. Our rate of interest is 5.25%. So again, we'll need to convert that to a decimal. And then we are trying to find time t. And again, remember guys, time is always in years. Okay, so let's go ahead and rewrite that rate of interest as a decimal. So what will we have for this guy?
.0525.
Very good. 0.0525 after your decimal place. Okay, so remember for the future value, your simple interest formula is FV equals P, and then in parentheses, 1 plus R times T. So we can go ahead and plug in all the known values we have. Our future value is 1863.12. Principal is 1700. 1 plus R as your decimal is 0.0525. And of course, we're multiplying that with T. So, this is your kind of like, with algebra, how we do equation solving, you get the unknown variable by itself. So that's going to be our goal over here, is to try and isolate that T by itself. So the first thing you want to do is you will see that T is inside the parentheses and you've got 1700 being multiplied on the outside. So the first thing we will do here is actually divide both sides by the 1700. Because remember guys, since you're multiplying by 1700, the opposite of multiplication is division. So that's why we're dividing both sides by 1700. And what this will do is get us the parentheses value by itself. And you don't even have to use the parentheses at this point. You can just have 1 plus 0.0525 times T. And then, whatever we get on the left-hand side. So what does that come out to be? Should come out to be, I think, a smaller number. Now, this is the part where I would say leave the number on your calculator as it is. And I'm just going to go ahead and write that down. We do not want to do any rounding at this stage, because if you round your answers right now, it will have a difference on your time. So don't round, keep all the decimals. So you've got 1.09509595291. And if you've got 1 or 2 less or more decimals, that's fine. But don't do any rounding. Keep all those decimals as it is. And you honestly can just use your calculator to keep performing the calculations. So remember, our goal is to get T by itself. So the first thing we will do is now get rid of this 1. So we will go ahead and subtract 1 on both sides. So that means on the right-hand side, you will be left behind with 0.0525 times T. On the left-hand side, if you do 1 minus 1, that first part will become 0, but all the decimals will stay. So you will have 0.09595291. So just, again, on your calculator, just go ahead and do that, subtract 1. And then what's the very last thing we are doing over here to get that T by itself?
Dividing.
Yeah, get rid of this R value, right? The 0.0525. So divide both sides by that part. And again, on your calculator, you already have the numerator typed in. So just, hit divide 0.0525, and you should know what your answer comes out to be at this point. Okay, if you will go ahead and share your answer with me. Okay, they didn't really tell us how they want us to put the time in this case. Okay, Logan, you got 1.82767507. Yeah, wonderful. That's what my calculator also gave me. So 1.82. Roman, did you get this answer as well?
Yeah, I got the same thing.
Yeah, okay, very good. Sandra, what about you?
No,
Okay, what happened?
I'm sorry. I'm driving. I'm going to my work right now, so I'm not.
Oh, you're not at home. Okay.
I'm listening in, but I just can't answer the questions.
Okay. All right. So like I said, since they didn't really give us specific instructions if they wanted us to leave the time in years, because this is what you are getting right now. This is the time given to us in years. Now, depending on your question, if they ask you to give you your time in days, all you want to do is to convert this into days is, multiply by 365, because that's how many days you have in a year, and you will be able to get your time in days. So we'll do both of those. And then, like I said, based on your homework, you can kind of decide, to leave it in years or to change it into days. Because this has to be a short-term loan, you're looking at 1.8 something. So how many days do you think this comes out to be? Slightly under 2 years. Yeah, very good. So when you multiply this, it comes out to be 667.1014006. So again, look at how many, roundings they want you to do, but for now, we'll just keep it at whole number. So in days, it will be 667 days. And then, if they want it in years, I would say approximately 1.8 years. So, they can ask you to find the principal, they can ask you to find the future value, but I thought this was kind of a neat example where you have all of those information. They really just wanted to know how long the money stays. I guess this was a loan since we borrowed the money. So for how many days or, how long you took the loan out for. So questions on this example over here, guys?
Nope.
So simple interest, can go through a lot of different applications, but that formula, the process will stay the same. Next time, I want to talk about, we'll still continue our discussion with simple interest. I just kind of wanted to show you guys a little bit of this, an example on the add-on interest loan, kind of like you go to those check cashing places or payday loans, I think some of them are called. I don't even know if any of them exist in Colorado anymore or not, but they kind of use this idea of the add-on interest. And then the other example I wanted us to look at was how the credit card finance charges are calculated. So we'll do those two examples next time and then move on to the next section in chapter 5. So for this week, guys, you are basically, just wrapping up your chapter 4. Roman, I think I already sent you your password last night. Okay, so you already have that. And then if I have received your emails, guys, I will go ahead and do that now as soon as we get done with class. And then, make sure you get those done by latest by Sunday night. The sampling and the bias homework that we just talked about at the beginning, that's due Wednesday. If you want to turn it in sooner, you can. I'll put all that information in D2L after class. And then I will see you guys on Monday morning. So have a wonderful weekend, guys. Be safe. And I will see you bright and early on Monday. Have a good weekend, everyone. Take care. Be safe.